Hello guys, welcome to Gweike Laser Factory. Today, we are here to reveal the secret behind the MCore. It combines 400-watt 5 laser and 80-watt CO2 laser into one machine, a clean and smooth workflow. These two advanced laser technologies work seamlessly together. To achieve this innovative integration, we have spent years of R&D. Today, we will show you the entire production process. What you are seeing right here is now the trial line of prototype. This is the real mass production line. So without further ado, let's get started. When it comes to fiber lasers, the core strength is the powerful cutting. MCore can cut through 5mm thick metal sheets in one pass. Carbon steel, stainless steel, aluminum, brass can all be handled with ease. CO2 laser, on the other hand, specializes in non-metal processing. With industrial top configuration, it can cut through acrylic up to 20mm, wood, leather, and many other materials in single pass. We have even developed our own dual laser integrated control system, perfectly merging fiber and CO2. When switching between processes, the workflow is smooth and effortless. We pair this machine with Gweike 2.2 kW air compressor. All parameters can be tweaked with just one click, and it's super easy to start cutting. Now let's take a look at the heart of the machine, the dual laser module. A high-end laser machine isn't just about power, it's about precision and stability. What you're seeing right here are the genuine original laser cores inside MCore. It is an industry first for a desktop machine to be able to cut and engrave both metal and non-metal materials. This is our laser source and complete machine testing lab. Our laser source can guarantee a 100,000-hour durability, stable, reliable, and no power drop over long-term use. Next up is a fiber laser production workshop, where we build the metal cutting heart at MCore, the 400-watt fiber laser. The workshop follows dust-free standards. Automated equipment and technicians work together on chip packaging, optical path calibration, and more, all with micron-level precision. The inspection is strict. We test power, pulse frequency, and beam quality to ensure stable cutting of 5mm metal with no burrs on the edges. We also run high and low temperature tests, followed by a 24-hour full load test. Once passed, it gets the label and goes into assembly. Now we are at the laser tube production and inspection area, where we produce the Gweike MCore's 80-watt laser tube. Our technicians follow industrial-grade standards for sealing, gas filling, and electrical packaging, wearing anti-static and dust-proof gear throughout. After each tube comes offline, it must pass strict checks. Output power test, 80-watt target with the plus-minus 2% deviation, plus a 12-hour no-load test and a high-pressure air tightness test. Only when everything is good does it move to the next assembly step, ensuring smooth and precise non-metal cutting. The guide rails are the key to high-speed and high-precision movement, and the inspection and assembly are extremely rigorous. During inspection, we use a granite platform as a reference and check rail straightness with a granite triangle. Then we go section by section using a dial gauge. After assembly, we calibrate levelness and parallelism again with a dial gauge, ensuring parallel error less than 0.01mm. Finally, we manually test the sliders for smooth, no stutter movement. The circuit board is the brain of the MCore. Fully automatic production, SMT assembly, AOI inspection, 72-hour agent test. Only boards that pass everything go into assembly. This is our cable assembly line, where all kinds of connecting cables of MCore are produced. Technicians monitor the wire diameter, insulation thickness in real time. For each batch, we randomly sample cables to test its tensile strength, high temperature resistance, and signal transmission performance. This guarantees no signal loss, even under long and heavy-duty work. After cables, we move to terminal crimping and wearing. Technicians cut terminal to size, frame precisely for solid connections. No loose contacts. Wearing follows drawings exactly, neat and standard. Then a power test checks signal and conductivity for electrical safety and signal stability. The MCore's 8-megapixel panoramic camera goes through strict calibration tests to ensure micro-precision positioning. Our engineer mounts a calibration board, starts a calibration program, and camera automatically shoots to adjust the distortion errors. We repeatedly adjust the camera angle, test positioning accuracy, and once verified, save parameters. Calibration done. Now we are in the sheet metal workshop. First, we do high precision CNC cutting. Second, we do the CNC bending.
0.05 mm.
The technicians will recheck and stack the qualified parts. Lifting table directly affects the cutting precision. Technicians using a high precision head gauge to measure the four corners and the center of the bed. Smooth lifting. For every MCore, we follow a one machine, which ensures a one report and one video standard. We test all key specs, generate a send acceptance report, and record a commissioning video. Kept on file, that's how we ensure every machine meets our quality standards, so our customers have a peace of mind. From laser core source to the smallest parts, from precise calibration to strict acceptance. We refine every single step. That's the hardcore quality confidence behind the Gweike MCore.